Okay, it is not doing the beeping for me, so I'm hoping this is recording okay. Today we are working on PO16. I can add and subtract fractions. So we are going to imagine for a moment you are a zookeeper, which I know is kind of a stretch, but just bear with me. Because there's bears at the zoo. Mr. Schultz is funny. Your zoo has recently gained a bunch of animals from a nearby zoo that closed. Would you add the new lions into the panda enclosure? No. Oh my goodness, that would be silly. Would you put gorillas and penguins together? No. I don't think I want to go to Elf Zoo because he would, and that might get a little scary. But most of us would say, no, I'm not adding those. Would you add the tropical fish to the giraffes? No.
I would.
The same logic though. I know some of us are being silly saying, yeah, add them, but it wouldn't go well. Same thing if we're adding or subtracting fractions. There's rules to follow, just like at the zoo. If you're adding two animals together into an enclosure that should not be together, it's not going to go well. If we're adding fractions together without following the rules, it's not going to go well. We need to follow those rules. We need to not be talking across the room to our friends, because that's very distracting to the teacher and to everybody else around us. So when we are adding or subtracting fractions, there are basically two rules to follow. The first one is that denominators have to be what? When we're adding or subtracting fractions, what do we remember from last year, Maddie? The denominators have to be the same. Just like at the zoo, we're going to put the lions with the lions. They have to go with the same thing. Same numbers, same animals. Our second rule is when we are adding or subtracting, those denominators stay the same. Every year I have students who want to add or subtract to those denominators. No. Once you get that denominator to be the same, it stays the same. Okay? So we don't just look at adding and subtracting and add the numerators across, add the denominators across. Nope. You have to follow these two rules or it will go bad for you. Guaranteed. Okay? You have to get the denominators to be the same using those equivalent fractions. We've been practicing equivalent fractions. Whatever scale factor we're using, we multiply the denominator and the numerator by the same number. We cannot just do the denominator. We have to do both the denominator and the numerator. So think of the denominator as telling you what you have, and the numerator telling you how many of it you have. So would 2 chairs and 3 tables equal 5 tables? No, because there's no such thing as a table. So we're not adding both the top and the bottom. We're not adding tables and chairs together. Right? So just like 2/7 plus 3/9 would not equal 5/16. You can't add that top and the bottom. So think of it as that bottom being chairs and the top is how many chairs we have. Okay. So let's practice doing some of this together. We learned this last year. Some of us remember it and go, oh yeah, I can do this. And some of us go, oh, I kind of remember Mr. Robinson teaching us this. It did not go well. That's why we're practicing it again. This is that important for math, it's gonna keep coming back. So we're doing it again so we can master it this time. So let's practice together. Add or subtract the fractions. Very important, show your work. And what's our final step with fractions? Simplify, simplify, simplify those fractions. Always see your final answer. Can I divide it down any lower? So if we look at this top row, what makes the top row so easy? Sarah? They already have the same denominators. Step 1 is already out of the mix for us. It's done. We only have to do step 2. You are only adding or subtracting the numerators and then checking if you can simplify. So we're not going to practice that top row because that's the easy ones. Okay? We don't have to do anything about denominators. We just add or subtract that numerator. Let's look at the second row. I have 1/3 plus 2/5. Now I have to do step 1 because it's not done for me. How do I do step 1? Bridget? Bridget says, well, I now, remember when we were talking about those equivalent fractions, I could just multiply the two denominators together. So if I look at 1/3, I'm going to want to multiply that by 5. So 5 times 1 is 5. 5 times 3 is 15. I am going to remember to bring down that addition sign because a lot of times when we have adding and subtracting all mixed up together, we might do the fractions correctly, but then we do the wrong operation. So make sure you bring down that correct operation. 2/5, I already have the 5 at the bottom, so this time I need to multiply by 3. 2 times 3 is 6. 5 times 3 is that 15. Now my denominator is the same, right? So that denominator stays the same. So I'm just going to put that denominator in as 15 right away, so I remember not to add them together. Now I have to add my numerators. What is 5 plus 6, Sophie? 11. So I get 11/15 for my answer. Am I done? How do you know I'm done, Lila? I can't simplify it any lower. There's no number I can divide out of 11 that I can divide out of 15 besides the 1. If I divide a 1 out, the number stays the same. So I'm going to circle my final answer. Let's look at my next one. 8/9 minus 5/6. What is my first step? James?
I counted denominators. I did 2 times 9 equals 18 and 6 times 3 equals 18.
So James said our first step is that common denominator. And he looked at the 9 and 16 and said, oh gosh, I don't want to multiply the 9 and 16 together because that's going to give me huge numbers. I know both 9 and 6 go into 18. So I'm going to put 18 as my common denominator. Because both 9 and 16 go into 18. So James said 9 to 18 we multiply by 2. So 8 times 2 gives me the 16. To go from 6 to 18, we multiply by 3. So 5 times 3 is 15. Now I know my denominator stays the same. Now I'm going to do my math. It's subtracting. So 16 minus 15 is 1. Can I go any simpler than 1? No, I don't have to think too hard about that one. I know I can't go smaller, so I'm going to circle my answer. Is that the only way we could have solved this one? No. Like I said, James said, oh, I don't want to have to do big numbers, so I'm not going to multiply 9 times 16, but I could have. Let's look at what would happen if I did that. I had 8/9 minus 5/6, and I multiplied that 9 by the 6, I would get 54. So 8 times the 6 gives me 48. Now I'm going to multiply the 6 times the 9. I get 54. 9 times 5 is 45. So I know my denominator stays the same. 48 minus 45 is 3. Uh-oh. I have a different answer. Why do you think I have a different answer? What do you think, Alan? I have to simplify. When I multiply my two denominators together, a lot of times I have to go back and then simplify if that's not that least common multiple. So I can divide a 3 out. 3 divided by 3 is 1. 54 divided by 3. 3 goes into 5 one time. There's 2 left over. 3 goes into 24. 18 times. I can't get any simpler. Oh, look at that. Now I have the same answer. Either way we do it, we end up at the final with the same answer. But 3 over 54 is a little bit harder to simplify. So sometimes you want to see, is there a smaller number, a least common multiple, that both of those denominators should go into? So I don't have to do that simplify. Because on the test, if you put 3 over 54, are you going to get it right? No, because you have to simplify. Any questions on our adding and subtracting fractions? It doesn't matter which one we do, if we're finding least common multiple for that denominator, or we just multiply the two denominators together to get those equivalent fractions. What matters is that we simplify it down and we get the correct answer. So do the way that works for you. So let's look at the rest of our page. On the bottom it says, write two fractions with different denominators that add to be 920. So we're going to have two fractions that are adding to equal 9/20ths. Could I put 1/15 plus 8/5? Would that work? But 1 plus 8 is 9, and 15 plus 5 is 20. Why can't I put that, Kylie? Because my denominators aren't the same. So I can't do it. It's not that easy. So I need to look to see, okay, I need different denominators that I know are going to go up to 20. What do you think I could put as denominators, Lila? But are those different denominators? So let's look at what Lila said, and we're going to work backwards to use her two fractions to work. So Lila said 1/20th plus 8/20ths. 1 plus 8 equals 9, 20, all stays the same. I can't use that because it's the same denominators. But what can I do to one of these fractions that she gave me? James?
I would do 8 fourths. No,
Would you really do 8/4? Sarah?
you could simplify 8/20.
I can simplify that 8/20ths. So I can keep 1/20th, and I can simplify that 8/20ths. I can divide out a 4 and say, okay, 8 divided by 4 is 2, 20 divided by 4 is 5. That is going to equal 9/20ths. So Lila did the first step for us. She said 1/20th plus 8/20 equals 9/20. Yep. And then we had to do Sarah's second step, simplify one of them. So now we have two different denominators. If we did the math and we multiplied that 2/5 times 4, all of a sudden we can get up to that 8/20. So on problems like this, you want to work backwards, just like Lila and Sarah did. Okay? Find what two fractions would equal it, and then make sure one of them you can simplify. Does that make sense? So on these kind of problems, we want to work backwards. Okay? Any questions on this page? Adeline? No. What's different about these two questions? They are not the same. What was the difference? Subtract. On the first one we added. On the second one, you need to do something similar, but instead of adding the two fractions together, you are subtracting two fractions to equal 9/20. So it's close, but there is a difference. So whenever you see something like that and you say, well, why would she have me do the same problem 2 times? Yeah, I wouldn't. So that's your clue. There is something different in the questions. Any other questions? All right, you are going to quietly work on this page. It's a 1-pager. I had quite a few friends who had missing assignments today because yesterday was one of those days where we had homework in math. It's not that often that we have homework in math. It's your responsibility to check at the end of the day, did I finish it? We lose points on that homework grade when we don't do the work. So today you're going to make sure you finish the page. Go back if you hadn't finished yesterday and make sure you finish yesterday's. Remember, Khan Academy is due tonight. Check to make sure you have all of your Khan Academy done. Remember, tomorrow is a retake day, so make sure you have any practice works turned in so we can do retakes tomorrow. If you have not gotten me the signed summary sheet yet, make sure you get your summary sheet from that last test signed and turned in. You don't have to wait for retakes to do that. That you turn in right away. That was due yesterday. So make sure you get those signed summary sheets turned in. Is it signed? Turn it into the blue tray. If you have a signed summary sheet, turn it in right now. Make sure you're working on those math packets. Math packets are due on Tuesday. If you are watching this at home, I hope you are well and I hope to see you soon. Have a wonderful day.